Hi, everybody. Thank you. Can you guys hear me okay? Okay, awesome. What an introduction. Thank you so much, and thank you to Solar Outdoors for inviting me here today. I think I might have to join this club. It's pretty exciting. I've got a few friends in it, and so really admire all the adventures that you all take, and happy to be here. So I'm going to advance my slides. There's a lot of them, so I may move quickly through some of them. Before I get started, though, I want to take a pulse. Okay, so every night when I think about whether or not I'm going to chase the Aurora Borealis, I pick up my phone and I look up a few things. It works on a computer too. I'm going to grab this right here and I'm going to pull up my best tool and take a pulse. Is it a good idea to chase Aurora? You can check the conditions during the day and throughout the day and watch how things are trending, and that can take you off to what you're going to do at night. So I want you all to remember this number: 17.3 gigawatts. Right now on the Ovation model, which you don't know much about right now, but you will see, we have 17.3 gigawatts of atmospheric power. Now, I'm gonna spoiler alert for you, it's not a lot of gigawatts. But by the end of this presentation, when I come back to look at this model of Northern Lights with forecasting, if that number changes, it might send us in a different direction tonight. So, dive in. You already heard a little bit about me. I have a background in journalism. I started my career as a journalist and made a transition into working in marketing and communications for colleges and nonprofits. I also co-founded the Aurora Summit, though. I've been doing that for 7 years now, and have been chasing the Aurora for over 10 years. So I'm pretty into this. Chasing the Aurora, of course, stays. I am a writer by passion and by training. Obviously, Aurora during the day I work as a science communicator, so I'm my official title at the UNC as Melissa Freebie. That is my legal name is Melissa Kaelin, is who I was born with. So Melissa Freebie at the University of Michigan is the manager of marketing and communications for the Department of Climate and Space Science and Engineering at UNC. So, woo, yeah, go blue. So every day I get to work very closely with undergraduate students, graduate students, and faculty and researchers who are studying the solar wind that produces the Aurora, and trying to learn more about the composition of the Aurora and how space weather, which you'll come to find out produces Aurora, affects us on a daily basis. So I also love it. But as I got up on myself a minute ago, I said, I have seen the aurora in 4 states. I actually saw my first northern lights up in Minnesota, where I lived for 11 years. I've seen them in Wisconsin at the annual Aurora Summit. That is a celebration of the aurora borealis. We call it celebrating the art, culture, science, and photography of the northern lights. And we hold it in the fall every year. Anyone is welcome to attend and chase aurora for a weekend. I've also seen aurora all over Michigan, including within 30 miles from this very spot, twice last year. So, and I've seen them in the Upper Peninsula as well. I'm still working on the Keweenaw Peninsula. I'll get there. After 10 years of chasing the northern lights, I decided to celebrate all the volunteering and advice I had provided in the community with a trip to Alaska, where I went with a group of aurora chasers with Cosmic Chaos Adventures. We put 11 of us in a van chasing the aurora all over Alaska for 8 days. And we were very fortunate with our chasing. We saw the aurora 7 out of 8 nights, including on the plane approaching Fairbanks, Alaska, and on the plane departing. So I saw it both times from the plane as well. Next up, the UM has actually agreed to take me on as a staff expert to guide a tour to Iceland for the UM Alumni Association and the Northern Lights, and that's coming this fall. So that's next. Woo! And I hear you guys are all about sharing your adventure stories. So I also have up here, usually the northern lights can be pretty tough to catch. There are a lot of factors that need to align. We need really great conditions in outer space, believe it or not, and also good conditions on Earth. So I'm usually chasing the aurora. But last year on April 24th of 2023, I was up in the Upper Peninsula, heard about a really great display headed our direction after the Upper Peninsula Dark Sky Festival, which is happening again this spring. And I was on my way home driving through the UP to get down here, decided to stop on a beach and see if right after sunset I could catch the aurora. I chased the aurora that night, caught it in an overwhelmingly beautiful display that I can tell you more about, and then decided after a few hours that I should maybe start driving home eventually for work on Monday. That night, the aurora chased me back. It followed me all the way down to the Mackinac Bridge as I was headed south during a really strong, what we call geomagnetic storm. So after chasing the aurora for over 10 years, the aurora chased me. How to catch the northern lights. So we saw a show of hands, which I always appreciate how many people have seen the northern lights. Now, how many of you here have seen them in full color? You can see the colors with your eye. Okay, not as many hands are going up. How many of you photographed the northern lights? Do we have some photographers in the room? Okay, we've got a handful. Cool, cool. How many of you, and this is just an estimate, I'm just trying to get a feel for whether you're kind of at the beginner level or you're feeling a little bit more advanced. How many of you would say you've seen the aurora not just once, which by the way is a bucket list item for people around the world to see it just once in their lifetime, but maybe 5 or 10 times? How many of you have seen it like 5 to 10? Okay, so we're still working on our skills here. I'm gonna teach you how to catch more aurora. So many factors have to align. And, I was interviewed for the local television station here in Detroit about a year ago. And they said, what does it take to see the northern lights? Does it take X? Does it take Y? Does it take Z? And I kept saying, it depends. Many conditions have to align, and it really depends what you're dealing with on how fortunate you're going to be. So we need the right conditions in outer space, because the aurora is actually formed by what we call space weather. This is activity that starts on the surface of the sun, produces these fiery hot balls of plasma and solar matter and solar wind that send particles toward the Earth. And then if all the conditions align, that creates northern lights. So we need good solar activity. It's got to be headed the right direction. And I'll go into this a little bit further. We need a good composition. We need a dense solar wind that's going high speeds, a favorable BZ. I'll teach you more about this in a second. And these conditions can change instantly. They can happen lickety split. We also, though, need the right conditions on Earth. So I told you we're going to see about going aurora chasing tonight. There's just one problem. Does anyone know what that is? Well, clouds. Michigan is the 7th cloudiest state in the country, come to find out. So it's difficult here. But also the full moon. It's the week of the full moon, and moonlight can be enough to wash out the lights of the aurora and make it difficult to see. One of the first things that I'll tell everyone they need to see aurora is starry nights. Now, that may sound obvious. Yeah, you want a clear night, gorgeous stars. That's what you need to see aurora. But if you look at this photo here, if you look really closely, we have the northern lights here over a lake and pinpoint stars that you can see right through the colors. So the aurora is actually a transparent veil of color. It's almost like air. And you can see right through it. If you can't see stars, you're probably not going to see aurora, because actually down here at the bottom, we might have some light pollution coming from city lights, something like that, that actually creates a really sort of murky, just hazy view. You can't see the stars as well. You can't see the Milky Way. You would have trouble spotting a comet, so you're not going to see the northern lights. But if you can see stars, that tells you have clear skies. You know, even at high altitudes, there are not going to be thin layers of clouds that are blocking your view, all mysterious like. It also tells you there's not fog or mist coming off of the lake or coming off of the forest that might obscure the view. And does anyone know what the biggest problem was last summer trying to see the aurora in Michigan? Wildfire smoke. So there are always these things that can really limit your view of the night sky. And if you're seeing the stars, that means you're seeing very high altitudes and you have a clear view, and probably no wildfire smoke, at least not enough to prevent you from seeing aurora, because that was the biggest problem last year, was wildfire smoke just murked up our skies so much we couldn't see much. So you need starry nights. Look for those stars. Honestly, when I go out chasing, if I feel like it's going to be a tough chase, the first thing I'm looking for is a star. And I sound like a crazy person. I'll just be looking at, is there a star? You see a star yet? Anybody got a star? So start there. You also need dark skies. So the darker your skies, the better. And unfortunately, when you live in the city like this or in the suburbs, you're getting a lot of light from street lamps and artificial light pollution. Believe it or not, if you're at your house and maybe you live a little bit further out in the suburbs and you have all the lights on inside and the windows wide open, that type of light shining out into your yard, if you're looking at the night sky, might prevent you from seeing something that's there. So when I'm aurora chasing too, if I'm at a cabin up north or something, I'll go in and I'll turn off all the lights, all the electricity, just shut it all down. You should see me in my car at night. I get in there and none of the lights come on. I can't see what I'm doing. But that gives you a darker atmosphere, a darker environment where you'll be able to see more at night. So ideally, head to a dark sky area. If you can't, though, try to turn out as many lights as you can and get to the darkest spot possible. The moon phase, this really does limit us in the lower latitudes. If you're going to Iceland, Norway, Finland, the moon can actually be a really great thing. It gives you great foregrounds and photos, great composition, great lighting to see where you're going, and you can still see the aurora. But at our latitude, the aurora has to be so strong to reach us, it really can sort of cancel it out and wash out the view. The farther north, the better to see the northern lights, obviously. And eyesight visibility. Some people have caught the aurora borealis, just not with their own eyes. So we'll talk about that too. So a few things to consider if you're going to go aurora chasing. You probably know a little bit about this, being outdoorsy folks who enjoy adventures, but scout out a good location. If you're taking your canoe to a river to kayak and you've never done class 4 rapids before, you're probably not going to put in right beside the rapids. You're probably going to find, a gentler side of the river, a softer part of the creek where you are comfortable kayaking at your skill level. It's almost the same with the aurora chasing. It's a good idea to go out during the day, find a really good spot for viewing the northern horizon, or maybe even photographing it, that you'll be safe in at night. And it helps you get a feel for your surroundings, what to expect there. It can also, if you scout out a location in advance, it can tip you off to overstreet headlamps that come on at night that maybe you didn't realize were there, or how bad the light pollution is surrounding you. That you can also run into situations where, there was a beautiful beach there last month, but after the rain, it all got flooded out and there's really nowhere for you to stand. So I encourage people, if you're going to go on a night adventure, it's good to know what you're getting into. Scout out a good location in the light and during the day so that you can prepare better for what's going to happen at night. You can use light pollution or dark sky maps to find those dark locations. Cloud cover and weather plays a role, so keep that in mind. Sunset, twilight, and moonrise and moonset can also be a factor. Even though the full moon is out this week, when that full moon sets, that all of a sudden gives us the darkness of the night sky back again. And so on a night when the moon is almost full, if the aurora is out, you could wait for the moon to set or get out before it rises, and you would have a better chance of seeing the color and seeing the aurora because you have darker skies. Twilight is tricky because if you've ever paid attention when, evening is falling and the sun is setting, right after the sun sets, the horizon takes on a really beautiful green. And I love that color, but that is twilight. So to see aurora, you really have to be looking for something much different. You can use the patterns of the northern lights to help you, though. A lot of people don't realize this. Sometimes there will be a really strong display of aurora. People will be seeing it overhead or in full color or at really low latitudes in Michigan. And it'll go away and you'll think, oh, I missed the show. But the aurora has patterns, and sometimes during strong displays, it comes in waves. So even if you feel like you missed that aurora, if you wait another 30 minutes, it might come back and come back even stronger. So know the patterns of the northern lights. And then another point, something to consider that I like to throw out there is the trifecta of safety, sleep, and sanity. So if you're going on an adventure, maybe stay within your comfort level of how you know you're going to stay safe. Keep in mind that a lot of places that you might go to see northern lights are going to be off the grid. You're going to lose cell phone service. You're out there at night. Towing companies will be closed. It's a little bit harder to get service in the middle of the night, especially if you're off the grid. So remember your safety. Sleep is important. Maybe you can van camp. You're living that van life. So you're all set with your vehicle and you can sleep in your car. Maybe friends up north that you can, take a nap at their place. Maybe you're camping and so you'll be out there all night anyway. Have a plan of where to sleep or know your limits. But the most important thing here, I would wager, is sanity. Because when you're chasing the northern lights in Michigan, they're really difficult to catch. So my number one tip for chasers in our area is if you're going out to try to catch the northern lights, plan at least one other thing that you're going to do on the way that's really exciting so that if the aurora happens in the 5 minutes while you weren't there, you still have a really good trip. So, this could be anything. This could be taking photographs of the sunset. I myself like to stop and take pictures of every 45th parallel sign. I love the 45th parallel. Or, maybe it's been 6 months since you've had a donut. Get the donut. At least if you miss the northern lights on your way home, you can say, well, I didn't see aurora, but at least I had a really good donut. Very important. Not the middle of 75. There's actually one that's off the highway if you go scout it out. So to be able to better track the northern lights and know when it's coming, especially to areas like ours, which are a lower latitude, it helps to understand what causes the aurora. So the aurora is created by the solar wind and space weather. And I talked about this a little bit. Really what happens is we have all this activity on the surface of our sun, which is a fiery hot ball of plasma and gas. And it's shooting off solar flares and filaments and high winds from coronal holes all the time. When one of those things erupts from the sun's surface and releases, sometimes they get sucked right back in. So don't let a solar flare fool you, because it needs to be ejected into outer space. But when that happens, it creates what we call the solar wind, which flies through outer space toward Earth's magnetic field and enters the Earth's atmosphere through the North Pole and the South Pole. And that's how we get the Aurora Borealis and the Aurora Australis on the South Pole.
Say that again, I never knew that.
Yeah, the Aurora Australis. You can see it from New Zealand and Australia when it's very strong. So this is tricky though, because monitoring what's happening on the surface of the sun, which is creating this space weather and this solar wind that is creating activity on Earth, a lot of things are happening. There's a lot of science to this. In fact, I'm working with some of the world-class researchers on the topic, and they're learning more about our sun and space weather every day. So what's interesting is any of that activity we talked about, firing off the sun's surface, takes 2 to 3 days to travel from the sun to Earth. So you think about the sun letting off light and lighting up our world, right? That light travels at the speed of light, right? It's here almost instantly. What, 8 seconds? But this plasma, this dense solar matter that's made up of all these particles, it takes that at least 12 to 14 hours, if it's going really high speed, to travel 92 million miles to Earth's magnetic field, or a lot longer. It takes between 12 hours to like 48, 36 hours to travel, 2 to 3 days really. Some sources will say 2 to 4 days for that to travel to Earth through outer space. Now, we have all these spacecraft that are monitoring what's happening on the surface of the sun. So we've got spacecraft that are positioned right outside of the sun, as close as we can get to study our huge ball of fire. And then we have a lot of satellites that are positioned outside of Earth's atmosphere and telling us, okay, what's coming toward Earth? What are we seeing on our side of outer space? And then you have all this stuff happening in between. That space weather could fire off in another direction. That solar winds could fire off at a high speed and then slow down and lose a lot of power before it gets to us. Sometimes these CMEs, as we call them, you can actually have more than one in a row, and they can combine. And then you either get a faster CME or a slower CME or who knows what. So there's 92 to 93 million miles in between the surface of the sun and the Earth where we don't really know what's happening. And we're trying to track this 2 to 3 days in advance. So these are some of the satellites they're using to track this. And one thing that we're teaching in the Michigan Aurora Chasers that's super important is there's also a gatekeeper. So you see this graph, here's the solar activity. Let's say this is a solar flare that's shooting off a coronal mass ejection, and that ejection is headed straight toward Earth to cause northern lights. The solar wind hits our magnetic shield. If it's able to, it forms a connection and enters Earth's magnetic field, and then it filters in through the poles. But Earth's magnetic field is naturally designed to protect us and to keep all of this space weather out. So the BZ is actually going to determine, okay, all of this matter has a charge. It's either going to have a polarity of positive or negative, kind of like a magnet. And Earth's magnetic field has a charge as well. And so BZ is going to tell us, are those charges going to create a connection where they connect and attract to each other, the solar wind to Earth's magnetic field, or are they going to create a connection where they repel? And Earth's magnetic field naturally pushes out any solar wind that would create northern lights. So I think I have another slide in here, but the BZ is what determines whether or not that's able to enter Earth's atmosphere. We've got some fun images here joining us. Let's see. All right. Not really sure. I'm not a PC user, so we might have a little trouble getting rid of this guy. But I will keep going. Swipe it to the side. Okay. Oh, it's
Minimize that.
okay.
Underline.
All right, we'll try here. I don't know, Bev, can you help?
I'm not sure either.
Okay.
But,
Escape.
That's a good idea. Escape usually works. There we are. Very nice. Cool, cool. So when that solar wind does make it to Earth's magnetic field and enters our Earth's atmosphere through a process where all these particles collide with other particles and get electrons and photons incited in Earth's atmosphere, what happens is the charged particles coming from the solar wind actually interact with molecules of oxygen and nitrogen and helium. And when they interact, that causes them to emit light. And that is how we get the colors of the aurora. So depending on what altitude you're seeing these particles at and this interaction at, that determines what the color will be. So at low altitudes, you'll see a lot of green because there's a lot of oxygen that's producing that color. At high altitudes, you'll see a lot of red from oxygen. And then we have air molecules like hydrogen and helium that create some of the purples and pinks, and nitrogen creates a rare blue. So that's how we get the colors of the northern lights. To track this though, it helps to understand some numbers. So all that solar activity, all that space weather is being measured on several different scales and forecasting models. And this is how you can try to track the northern lights. Who here, we have some aurora chasers in the room, who here has heard of the KP or the K? Yep, so aurora is almost always measured on the K index, which is really just a simple scale of 0 to 9. 0 is the lowest, 9 is the highest. The K index tells us, okay, how strong is the aurora going to be potentially based on what we're seeing? And the trick is when you see KP, P for planetary, that's actually a planetary average of the K value, which is measured at different locations around the world and averaged together over 3 hours to tell you, okay, the planetary average of aurora strength right now is, let's say a KP5, but that is averaging locations around the world over the last 3 hours. If you open up a forecasting app and see a KP5, which is pretty good high aurora number, that could be referring to 3 hours in the past. So, but this is your K index. Anything below a 4 and below is really considered very normal activity. At KP4, you might see aurora in the Upper Peninsula. KP5 in the green here is when we hit storm levels. Then KP6, KP7, KP8, it goes all the way up to max out at KP9. Storm levels, what is that? Well, aurora is actually being created by what we call a geomagnetic storm. This is a type of storm that produces aurora. It also has impacts on our infrastructure and our electrical grid, our power grid. So the National Forecasting Agency, the Space Weather Prediction Center, has come up with a scale to tell you, okay, at what K level or KP level are we at storm conditions? Once we hit K5 or KP5, we're at a G1 storm. This is considered a minor geomagnetic storm. On the power system, we may see weak power grid fluctuations. It can have a minor impact on satellites in outer space and those operations. Migratory animals might feel the effects. And then if you read the very bottom of the scale, aurora are possible at high latitudes, including northern Michigan and Maine. So G1 is a K5 or a minor storm. G2 is a K6, that's a moderate storm. It's gonna cause voltage alarms to go off. It could cause problems in orientation with GPS and satellites. And aurora may be seen as low as New York and Idaho. At a K6, a K7, which is a G3 storm, that's a strong geomagnetic storm. At this level, aurora has been seen as low as Illinois and Oregon. And then we get up to G4, which is the same as K8. Aurora has been seen as low as Alabama and Northern California. We max out the scale with G5, which is the same as K9. Aurora has been reported as low as Florida and southern Texas. And actually, in the most powerful storm ever recorded called the Carrington event, Aurora was seen all the way down to Cuba. So it is possible. Last year we had a couple, how often? Last year we actually had we had 2 G4 storms. We haven't seen a G5 in quite a while. It's been 10 to 20 years at least. So they are rare, but the G3, G4 storms are hitting us more often. The thing about the K index though, remember that when you're looking at KP, that is averaging 3 hours together, taking measurements from around the planet. It's also used more for forecasting. So you can talk about what the Aurora forecast is with KP, but when you get to the actual night of chasing, you're gonna wanna look at other numbers to know what's actually going on. And that's how we get to the ovation model, which is what I looked at when I started my presentation. So this is what I use to chase the Northern Lights, and I would swear by it. It looks really tricky, but actually what you're seeing here is a slice of the top half of the globe, so the Northern Hemisphere. This is the North Pole right in the middle, and the aurora actually rises and sets just like the sun, but opposite the sun. So the auroral oval then rotates around the North Pole following night and sort of receding during the daytime. And if you look closely here, you can see there's a line that shows you where nighttime is on the globe, and then the lighter color is daytime. So the auroral oval there, it also will become more colorful when there's a higher probability of northern lights. So I'm going to tell you how to read this really quickly. It looks confusing, but it's actually quite simple when you get what they're trying to visualize here. Up in the top, you'll see this is the NOAA Space Weather Prediction Center Aurora forecast. And they're going to tell you it's for 2022-09-04, which is actually Labor Day of 2022. Then they're going to give you the time in universal time, 0602 UTC. That just means 0600 hours and 2 minutes in universal time, which we have to convert for our time zone. So basically, this is the aurora forecast for this date and time. At the cata corner to that, you just see the title of the model, Ovation Aurora Model. They'll tell you the model runtime in the same format, and then the time the observations were taken at the L1 point, which is where the satellite is stationed in outer space, taking this aurora data. So again, aurora forecast for this date and time. This is the model runtime and the observations when they were taken. And then we get to the good stuff. We've got this visual of the aurora oval. If it's just a light green, that's telling you there's not much aurora. If you start to see yellow or red, you're going up the scale of a high probability of aurora. And it will actually visualize, this is Michigan here, when the aurora is going to come overhead in Michigan and other states and around the world, obviously. So that's what you're seeing. And in the top corner becomes the really important part. They're going to tell you how long it's going to take this combination of factors, basically the solar wind speed and strength that they're tracking in outer space to reach Earth. So this has a forecast lead time of 42 minutes. In 42 minutes, we're going to see aurora at a hemispheric power of 104.3 gigawatts on a range of 5 to 200. So what I like to look at is that forecast lead time and how many gigawatts of hemispheric power are we getting tonight in this short-term forecast for aurora forecasting. So 42 minutes, 104.3 gigawatts, that's a lot of gigawatts. And we've got a lot of red on the map. We're going to see a high probability of aurora as it rotates following night around the globe. So that is a really great ovation model. And that's what you want to see, especially if you want to see the aurora in southern Michigan. Now there's something to watch out for though. This model has become really popular. You're going to see it everywhere. You're going to see the video format. The video format is tricky because you could watch a really great oval rotate around the world and say, oh, it looks so good tonight. Well, most of that is the last 24 hours up to the last second or two of this video, and then that gives you the forecast. So if you're seeing the video, just be warned. Most of it's in the past. You'll see the forecast version. This is actually on the homepage of the National Forecasting Agency, so it's right there. Anyone can find it any day of the week. What do you notice about this one? A lot of red, yeah. This was actually forecasting a KP5, which is a minor geomagnetic storm. And there's a lot of red on that ovation model in that forecast version. Experienced aurora chasers agree they are sort of exaggerating that forecast model. It is not going to be as good as that looks. So if you're looking at the forecast version, take it with a grain of salt. Now, the real-time model is what I have linked on my phone. It's what I have linked in all of my presentations, what I share in the Michigan Aurora Chasers, the group that I created. This is actually going to give you that real-time lead time of 42 minutes and a realistic version of what the aurora oval will look like coming soon near you. So I highly recommend using that version. You can find it on my website at kaelinart.com/aurora. Or we can make sure you have it at the end of this talk. Another thing you'll want to watch is the trends. If you really get into this, you'll want to study what's trending. So from bottom to top, this is the composition of the solar wind we're seeing in outer space. Temperature is at the bottom in green, not super important for aurora chasing. Speed is in yellow. This is very important. The faster the speed, the faster that potential aurora activity is coming at us. We usually like to see at least 400 kilometers per second, if not over 500 is much better for a good aurora display. Density in orange is important. But density goes all over the map. As long as it's, up to 1.0 or all the way up to 32, the higher the density, the better. In fact, the higher this orange line, that means the denser the solar wind, the more particles coming at us, the more potential we have for those to interact with air molecules and emit color, and lots of color. So higher density means better colors. Phi in the blue is not super important. And then we get to the make or break of aurora chasing. The BZ is on top. So that pesky BZ, what is it? Well, each solar wind ejection has its own magnetic field. And it's either polarized to the positive or to the negative, like I mentioned before. Earth is polarized to the positive or northward. So we need that BZ for strong aurora to be polarized negative or southward for that to form a connection. So here in red, you'll see a line for BZ. And the scale says 0, it goes up to 5, 10, or below that, -5, -10. We want it in the negative. The farther negative, the better for BZ. We want that red line to go below 0 and drop it like it's hot. So we also want to stay negative. Now, if BZ is positive but not very far positive, that means we still could have hope that it could change to the negative and we could get aurora. If BZ goes positive, negative, positive, negative, positive, negative, well, it functions kind of like a door, a gatekeeper, to let that flow of energy into Earth's atmosphere. That door is swinging wide open and wide closed and wide open. And what that is doing is actually creating instability in Earth's magnetic field and letting the aurora flow, believe it or not. So if you see it going back and forth, that's a good thing, as long as it doesn't stop or get pinned in the wrong direction. If BZ goes all the way to the top to +10 and stays there, though, that's bad news. And the way that you can tell if it could do that is to watch the other number on the top graph, BT. BT is the potential of the BZ to go in either direction. So I look at this graph and I'm like, man, there really is no BT on this graph, is there? But there is. It's all the way at the top. It's right at 10. So BT is up there near 10. It's the little tiny white line that you can barely see. And BT is always going to be positive. It's always going to be above 0 like that. Actually, the higher it is above 0, the better. So if I'm looking at this graph right now and Ovation is telling me that, the models don't look very good tonight, there's probably not going to be much Aurora. Do I even have a chance? Well, I'm going to start looking at my numbers. Okay, solar wind speed is low. That's depressing. Density is good, not great, but it's good. Phi, we don't need that. Temp, we don't need that. We've got BZ hanging out around 0, dropping below, going above, dropping below. BT is telling us the potential of that, though, is at any given moment, BZ could drop to -10 or go to +10, flickety split. So the higher the BT, the better. When we see those large BT numbers, that usually indicates that a lot of power is building behind the scenes, and at any second, that BZ is just going to flip, and the Aurora is going to come rushing through. So watch those numbers and look at that potential, and monitor the trends of BZ if you really want to know if you have a chance at seeing Aurora. So we all love Aurora photos. Here's some photos I took on my iPhone 14 in Alaska in 2022. Phones are getting really good now, but cameras are ideal. And Aurora photography is really subjective. If you want to photograph the Northern Lights, the best thing you can do is get out there, start photographing the night sky, start practicing, start adjusting your settings to see what lets in more light, what feels like too much light. You're definitely going to need the right equipment. You're going to need a tripod, otherwise nothing will be in focus. You'll probably want a remote so that you don't bump that tripod. Extra batteries. When you're photographing in the cold, those batteries will run out of power at night. You don't need to zoom in. A telescope is not going to help you here. So get the widest angle lens you possibly can if you want to photograph Aurora. And any modern digital camera should do the trick. You really don't need fancy gear. A lot of people are recommending the 6D as a starting point. Smartphones within the last few years, that cuts off on that slide. Got to fix that. Those will work too, especially if you have a tripod for your cell phone, believe it or not. The right settings, these are really going to vary, but you're going to want to shoot in manual mode and turn off your flash. Like I said, wide angle, the longer shutter speeds are going to let in more light and give you more of that color, but they also might take away some of the definition. Aurora are not only colorful, but they also take shapes and formations. They look like pillars or stripes or waves, or there's one formation that we call the dunes. They look like sand dunes. So the longer your exposure, you're going to lose some of that definition and detail. So adjust as you go and really use the exposure triangle to your advantage. I feel like I'm running late on time, so I'm rushing through a few of these. But here's some photos I took in Michigan.
You have plenty of time.
Okay, great. This is actually taken by a friend of mine. That's me, that little set of pixels in the middle in the Upper Peninsula on Lake Superior Shore. That was the spring.
Were you pointing them out?
What's that?
Were you pointing them out?
Yeah, it's funny when you strike a pose at night, you're like, okay, what should I do? And I think, I was just giving him a shout out. But that was the spring equinox of 2021. And then these were both taken last year, not too far from here, on my iPhone. So this is actually north of Flint, Michigan, March 23rd, 2023. Is anyone kind of looking for a starting point of where to see Aurora without going far from home? All right, we're going to keep it in the club here. But Bluegill Boat Launch, if you look it up, great parking, not huge, beautiful, safe, northern view right over the lake. That's where I took that photo. And it only took me an hour to get there from Ann Arbor. This was taken southeast of Lansing on February 26, 2023. So those were those 2 G4 storms we had. And this color, a lot of times when you're looking at Aurora photography, the camera is going to capture more light and color than what our eyes can see at night. You really have to let your eyes adjust to the darkness and think about the limitations of our night vision as humans when you're chasing Aurora. The camera is not human. It doesn't have night vision. It catches all light and color in the sky. So when you're looking at Aurora photographs, ask the photographer, well, how much could you see with your unaided eye? How much of that color could you actually see that night? Because you might be surprised. In this photograph, the colors were a little bit duller than that to my eye. Now, during these really strong geomagnetic storms in Flint, I would say the color wasn't quite that neon bright, but I was seeing a lot of color that night, pretty close to what you see there. And then during this Lansing show that I caught, all those colors were just visible just like that to my eye. So it was really beautiful. All right, so chasing Aurora in Michigan. We talked about the K index and the KP. Once you know what value KP you need at your latitude, you can start to watch those forecasts for a heads up of when to be alert. So this is a KP map. It shows you how KP maps out across the globe. KP3 is usually good for Canada. We only need a KP4 to see northern lights overhead in Michigan's Upper Peninsula. KP5 then starts to push Aurora overhead to Mackinac City and down to the 45th parallel of Michigan. My book is called Below the 45th Parallel, and I love the 45th parallel for that very reason. We only need a G1 storm to get Aurora there. Once we get a KP6, which is not a line here, Aurora are possible in the entire state of Michigan if you have clear, dark skies. So all we need is a KP6 or a G2 storm warning. KP7, then they push down into Ohio. KP8 farther down into the United States, and KP9 all the way down to Florida, potentially. It is, yeah, you kind of had to dig for it, but it's there.
This is much better.
and we decided Michigan needed its own version. so in the Michigan Aurora Chasers, I created this map. What parallel do you live near? Figure out what parallel you're at. You can even look it up right now. What latitude is Livonia? And I didn't tonight. I'm guilty. I would say above 42 degrees north. So all we need to see Aurora overhead here is, in theory, a K6 or a KP6 equivalent to a G2 storm. And then it should be visible overhead. Now, will that happen in Detroit? The skies aren't very dark, so you might not really see it, but it's there. At a K5, you can start to see the yellow. This is going to map out where a G1 storm would be visible across Michigan, and that's just a G1 storm. It's going to be straight overhead in Traverse City area, Grayling, right along the 45th parallel, and it's going to still be visible in parts south from that. K4 is going to cover just about all the UP. It's visible there overhead, and that's below storm levels. But anything stronger than that, we should see it even better and even brighter. So to map out the chase, know what KP you need, know your latitude or what parallel you live at, and then part 3, figure out your light pollution situation. So in the cities, this is really the kicker. But you can just do a quick search on Google for light pollution maps or dark sky maps. You'll find some good ones, and lightpollutionmap.info is a really great one. Here are a couple of light pollution maps kind of looking at Detroit. Let's see. I think this one is still... That one maybe didn't update, but so we've got, you can see all of Michigan here, and this is Detroit, and Livonia is going to be right over in this area. Unfortunately, anything in the red and orange is going to be really, really difficult to see Aurora. If you zoom in, you can start to see where these light pollution centers become more orange and green and less red. Get out into those areas and you might have a better chance of seeing the northern lights. And I actually started a YouTube channel where I walk you through some of this. I put up a video on how to really zoom in on light pollution maps to find your neighborhood and pinpoint where you live and what parks are near you. And you can use that to sort of gauge, okay, how bad is the light pollution, let's say, just southeast of Livonia? How bad is it over near Brighton? How far would I have to go? Do I need to go north? Is there a a spot that's a rare oasis in my neighborhood that I didn't even know was there. So if you zoom into light pollution maps and learn how to use them, you can really pinpoint some dark sky areas. Cities are not a dark sky area. Unfortunately, on the Bortle scale, we're all the way up at a 9. The Bortle scale rates how dark the skies are and how likely you are to have good night sky viewing. And when we're right in the city, we have Bortle 8 or 9. In the suburbs, we get a Bortle 7, which is probably what our skies are right here. Mine in Ann Arbor too. Well, actually, I think I have some areas that are Bortle 5, Bortle 6. But the more you get into the country or the further you go in northern Michigan outside of the cities, the more you'll see some Bortle 4 and Bortle 3 and very dark skies. Oh, here it is. I knew I had Livonia in here. So this is actually a close-up of Livonia would sort of be right at the bottom in here. You can see as you head straight east, you get a little bit of a break. Now, if you have light pollution, west, thank you. If you have light pollution directly to your north, though, wherever you are, you're going to see that on the northern horizon as you look for the aurora. So you can zoom in and you can also see some of the orange spots, some of the different spots of reprieve a little bit, and where you might need to go just north of Detroit to get a break from those dark skies. That's where my maps went. So the KP, the Aurora forecast is issued by the Space Weather Prediction Center, our national forecasting agency, and you can get a breakdown of KP and universal time in 3-hour increments for the next 3 days. Because again, because of what's happening on the surface of the sun, we can only predict aurora 2 to 3 days out. So this is what one of those SWPC forecasts looks like. It's going to give you the day, the KP rating, and they're using fractions now, if it's equivalent to a G storm, a geomagnetic storm, and those 3-hour increments in universal time. So you can sign up for those as well and get alerts about aurora where you live. Or you can join the Michigan Aurora Chasers. It will help you out. So I'm going to sort of like try to use a PC correctly and also wind down my presentation a little bit and open it up for questions. We have a lot of fun in the Michigan Aurora Chasers. We lead live chases. We were able to catch Steve. Has anyone heard of Steve? Steve is a sub-auroral arc that is not actually an aurora, but it's related to an aurora. And it doesn't appear in the northern sky. It appears a little bit to the southwest. These stripes here are the picket fence, and Steve is like a purple or red ribbon across the sky. So you'll see Steve as a ribbon across the sky, and then the stripes of the picket fence. And our Aurora Chasers have caught Steve in Michigan. They've caught Aurora in Michigan. We share a lot of great photos and updates, and we try to wake each other up when the northern lights are out. And we have contests. We hold an annual workshop up north. We're just trying to help each other catch and photograph more northern lights. So you're welcome to join us. We're also on Instagram now, My Aurora Chasers. And we've got lots of our resources, including that ovation model on our link tree, which is a website there. It's linktr.ee/MyAuroraChasers. So what kind of questions do you guys have? I also wrote a book, a guidebook to help you out. I see one over there. Yeah, in a second. Yeah, go ahead.
I'm sorry, you mentioned you had a YouTube channel.
Yeah, the YouTube is at Melissa the Aurora Chaser. It's here. So feel free to check that out. And you wanted me to go back to the ovation model? Oh, the link. Okay. There it is. Yeah. Cool. Other questions? I feel like I went fast tonight, so don't be shy.
The aurora is much more visible on the changes of the seasons, like on
Yeah. So a lot of people have told, sent me messages on the solstices, hoping I'm excited. It's not actually the changes of the seasons, though. There's something called the Russell McPherson effect, which is an effect that to where the aurora is more common at the times of the spring and fall equinox. And that's because the peak season for aurora viewing actually falls in the winter months. It falls between September to April of every year. And we really are sort of our openness to that negative BZ is more common during that time of year and around the equinoxes based on the tilt of the earth, which allows us more aurora. So that's what you're looking at. It's really the spring and fall equinox where it's more common.
Does that depend on where you are? Like is Norway different or what?
No, it's true for the entire globe. Really, what we look for in Michigan is really, really strong aurora and really powerful aurora. So around those times of the equinox, we're going to be looking more because that stronger aurora pushes farther south from the North Pole and gives us a better chance. But it would still be more powerful up there too. Yeah, and this is actually the year of solar maximum, which I haven't even put into my presentation this year. 2025, it's supposed to be an 11-year high of solar activity that creates those aurora. We've seen a lot of X flares firing off the surface of the sun, but unfortunately, they've all been pointed away from us and none of them have come to Earth yet. Yeah, so we talked about that solar activity and that space weather that really creates the aurora. The sun itself functions on what they believe is an 11-year cycle, or in older days, they thought it was a 22-year cycle, where it has sort of a calming, you don't see a lot of activity on the surface of the sun, and then towards solar maximum, you see lots of solar flares and lots of filament eruptions and lots of coronal holes and huge sunspots. All of that activity can create more of this space weather that then can create aurora. So that's why we're in the maximum of the sun's solar cycle, and then we'll start gradually heading down towards solar minimum after potentially this year. We're hoping it works out. This is the solar maximum and minimum are a forecast as well. So sometimes scientists look back at the data and the numbers and they have to reevaluate and say, okay, well, maximum didn't really hit in 2024. It actually hit in 2025. So global warming is a huge issue and climate change is a real challenge, but aurora has nothing to do with it. So, yeah.
Does the solar maximum have anything to do with, I read something about the pole switch.
Yeah, so the poles of the sun do flip, and that's exactly what that ties into, is that cycle of the sun has to do with that flip of the poles on the sun. Yeah. Do you guys have any other questions? Has anyone tried to see an aurora and failed miserably and wondered why? The bluegill boat ramp. Yeah.
I do know, Chris Ann and Leslie and I were up, my cottage is just north of Alpena, and we drove up to the harbor. And I never realized that what we were seeing, the pictures were a hell of a lot better than what we could do.
So much better. And
Yeah.
I was following your Facebook page, and I just kept sitting on the couch and I was whining about it. And she finally said, "Do you want to go?" And I went, "Yes."
As they said for the broadcast online, up north, they didn't realize that they were seeing the aurora because it wasn't as bright as it was in the photos. And actually, that surprises a lot of people. Sometimes you can look out on the northern horizon and the aurora will only appear almost like a cloud because it'll look kind of silver or white in color. And it's not going to look exactly like a cloud because aurora has its own formations and shapes and patterns that it forms as it grows and expands. But you might, the first time you see aurora, only see silver or white and not the colors, because depending on how strong the storm is and how high that density is and how many particles we have interacting with light, that really determines whether you're going to see the color or not.
So many times on your page, there's photos that people post that there's actually light pollution.
Yeah.
So how do you things to look for to cover there.
Right. So a lot of the photos in our group are light pollution. What are some key things to look for to tell the difference between light pollution and aurora? Well, I would say those formations and shapes is a big one. So light pollution, the first thing that I do when I'm looking at light pollution is I'll look at it, several times of the day or several minutes of the hour to determine, has it moved? Is it moving? And this can be a little bit misleading because if you got the spotlights or, something's flashing, like it'll look like it's moving a little bit. But most light pollution doesn't really move. You can look north or you can look outside your back window. Well, you want to be outside if you really want to see the aurora. So in your backyard, and you'll see that light pollution in the exact same place all night. So the first thing I would say is it doesn't move. I would also say look at the color. I like to think of the auroras having a really natural color. And sometimes it almost looks neon. So like a really bright, natural hue. Light pollution often has more of a yellowish orange color and more of sort of a muddy haze. I think it looks kind of almost muddy to the eye because it's not super brilliant. It doesn't remind you of nature. It looks more like something you might see I don't know, on the TV or something. But other things you can look for is the aurora will form an arc when it's low, when it's just starting out. The auroral arc will actually appear almost like an arch in the northern sky. So if you see that shape or a little bit of curl to the clouds that you're looking at, that could be aurora. Now, if it starts shooting up pillars, or you can see some of the wave formations. If you can see those, then I think those shapes and formations are sure signs of the aurora. Other ways to know it's light pollution. Sometimes when something is really throwing me and I'm aurora chasing at night, I will take a drive. We had a member in the Michigan Aurora Chasers who had the hardest time catching the aurora. She would always post sightings of the aurora, but the thing is, it wasn't aurora. And it was in the same spot every night. And it wasn't really rising up into the sky or moving. Aurora will also move and change. There you go. I finally said, why don't you take a drive in that direction? Better yet, if you can do it at night and see if there's anything there, because I really think what you're seeing is light pollution. And sure enough, she took a drive in the middle of the night and found out there was a big industrial sort of warehouse right there, sort of out in the country that she didn't even know was there, that was producing all this light. So if you are chasing aurora in the same place every night, you can drive out and identify what those things are that you're seeing. The thing that's throwing a lot of people off up near Canada is they have a grow house that turns the sky purple at night. But it's the same purple every night. So, yeah. Yeah.
I was just going to tell you, I've seen the aurora twice, and neither time did I know what I was looking at.
Okay.
The first time I saw it was up near Grand Rapids when I was in college. This was many, many, many years ago. My roommate and I were driving back.
Mm-hmm.
I'm a city girl. I was born and raised in Detroit. I've lived in the area all of my life. I thought it was aliens.
Aliens. Yeah.
And fortunately, that was before the era of cell phones, because I kept yelling, "It's the aliens! It's the aliens!" I don't think so.
Right. Yeah. The aurora, when you do see it, or if someone sees it for the first time, it can be really surprising and not knowing what you're looking at. Especially if you haven't been out under the night sky a lot, there are a lot of things that will surprise you. I had a friend, recently we were chasing aurora, and I think it's been a while since that friend got a lot of time out at night, but Starlink passed overhead. The huge network of satellites that goes around the globe every single night and day. And how many have seen Starlink at night? It's like a long train of lights. You're like, oh, that's an alien invasion for sure. Like they are all coming to trade for us. If you haven't seen it yet, it's really surprising to see for the first time. You can even know in your mind that's Starlink and be like, whoa, is that Starlink? Yeah.
When was that event that you had in the fall?
Yeah, I led a live chase in Tawas City last September, and we actually had a group of over 50 people come out to chase the Aurora. The numbers had looked good. That pesky BZ, as we say in the group, was not cooperating. So we all stood out there and we had some clouds low to the horizon, and everyone's going, oh man, oh man. And we waited for 2 hours and saw nothing. And then half of the group left. And those of us that stayed then saw the cloud dissipate, the aurora start to glow, and pillars shoot all the way up into the sky. And Steve came out, the subaurora arc, at the end of the night to conclude our festivities. So yeah, so it was September, and we did catch the northern lights. But you had to be patient. Yeah.
How long do you normally sit out there?
Yeah, how long do you normally sit out to try to catch the aurora? I have started recommending give it at least 3 hours. And I know that sounds like a long time, but if there's been a display or a little bit of aurora, maybe for 20 minutes, 30 minutes, and it just went away, it might take another hour or two for it to come back or come back with any strength. These 3 hour periods really kind of represent a little bit of the pattern that aurora takes. And so if you can devote an entire 3 hours, you're likely to see something in that block on an active night. Now, it's tricky though, because one of the most popular displays that I've seen in the Aurora Chasers group, the Michigan Aurora Chasers, happened over Labor Day in 2022. And there were all these people that were so happy and so excited and just over the moon at what they saw, and the colors were the brightest thing I'd ever seen in my life, and it was naked eye visible, and it was so stunning. And then there was another half of the group that was so disappointed and thought the night was a total bust and a letdown. And I thought, how is this happening? These two sides are telling completely opposite stories. Well, in the Michigan Aurora Chasers, when you post a live sighting, you'll let people know aurora are out by including your time, date, and location. And I looked at all the timestamps on all the photos from all the people that were really excited and really happy. And I looked at all the times that others were reporting there was nothing out. The brightest part of the aurora that night happened inside of 15 minutes. So think if you had been out aurora chasing all night and maybe you were the only one there or something, you went inside to get a cup of coffee and you decided, well, I'm kind of tired, I'll take my time. And, you go back outside, and in that 15-minute span, you missed it. So it's really tricky. It really does take a lot of luck to catch the aurora. Yeah.
If there's one place in the world you would go to see the most spectacular,
Yeah, if there's one place in the world I would go to see the most spectacular aurora, where would I go? What's that? Svalbard. I have been dreaming of Norway. I think I would go to Norway. I went out to the Arctic Circle when I was in Alaska, and I highly recommend that. But I think seeing it in the fjords and, with all those dramatic landscapes, that would be incredible. Now, what's my dream destination? I've decided I want to see the Aurora Australis someday. So, New Zealand. But that'll be harder to catch.
Okay.
Thank you, everybody. Thank you so much.
And Melissa will be right here with her book if you are interested in doing more of the document of this stuff.
we've got about 10 minutes or so, maybe 15 minutes.